Hey guys, so in this one we're going to be talking about exponential versus linear growth over time. So we're going to have an exponential situation, we're going to have a linear situation, we're going to be comparing them. That's basically how these are going to work. So bear that in mind as I'm reading the question. Alicia has invented a new app that two companies are interested in purchasing for a 2-year contract. Company A is offering $10,000 for the first month and will increase the amount each following month by $5,000. Company B is offering $500 for the first month and will double their payment for each following month. So, if we remember, our linear is when we are adding the same thing each time, and exponential is when we're multiplying by the same thing each time. So company A is going to add $5,000 each month. They're increasing by $5,000, right? So they're adding $5,000 each month, so that's linear. Company B is doubling each month. Remember that doubling is the same thing as multiplying by 2. So company B is multiplying by 2 each month. So that's exponential. So company A is going to be linear, company B is going to be exponential. So let's remind ourselves of what our linear formula looks like. Right? So in the case of a word problem, B is your initial amount and M is the amount you're adding each time. Okay, on a graph that's y-intercept and slope, but in a word problem, it's initial amount and the amount that you're adding each time. So company A is going to be y equals, we're adding 5,000 each time, x plus the initial amount is 10,000. So that's our formula for company A. Company B is exponential. So remember, exponential is y equals ab to the x, where A is our initial amount and B is the amount we're multiplying by each time. Not to be confused with this B. These are two different B's, okay? So initial amount we're multiplying by each time. So the initial amount was 500. So y equals 500 times 2. Remember, we're multiplying by 2 each time, doubling, multiplying by 2 each time, times 2 to the x. So this is our exponential formula. This is our linear formula. Okay, so then the question says, for which monthly payment will company B's payment first exceed company A's payment? So company A, right, starts up at 10,000 and company B starts at 5,000. So company A starts higher, but because it's linear and B is exponential, B is going to pass it at some point. So we want to find out where it is that company B's payment is going to pass company A. So there are 3 ways that we could do this. The best official way would be to set these two equal to each other, right? I want to know where they cross. So if I set them equal to each other and solve for x, I would know exactly where the two payments cross, and then the next whole number above that would be the first month that B's payment is greater than A. However, we don't know how to solve that because we don't know how to solve an equation that has an x in the exponent and an x outside of an exponent. We don't know how to do that. So we can't do that. So the first option is off the table. The second option is guess and check, right? I could plug in x here, plug in a number for x, plug in the same number for x in this equation, and then just keep doing that until this one gets bigger than this one. That's an option. I could do that. So if that's what you're comfortable with, that's an option. The best way I think for us to do this would be to graph both of these and look at where they cross. So I'm not talking about graphing by hand. I'm talking about using a graphing calculator if you have one, or online graphing software. So I'm going to be demonstrating this with Desmos graphing calculator. So I have this. Desmos.com is a good graphing calculator, good basic graphing calculator. So I'm going to go over here. And I've already put in our two equations, okay? And I've already found where they cross. So the way Desmos works, you put in the equation, and if you click on the line, you can see it will tell you where it crosses the x-axis, where it crosses the y-axis, and it will tell you where it crosses other graphs. So it'll, by tell you, I mean it will put a dot there, and if you hover over the dot, you can see that intersection point. So these numbers are huge. These numbers are huge. It actually took me a while to find this point because the numbers were so big. I had to keep scrolling up, scrolling up, scrolling up. But once I did find it, I was able to see that x, which is what we care about, what y is, that big number doesn't really matter. What we care about is what x is 6.3, which means it's between 6 and 7. So the first month, since they cross between 6 and 7, the first month that B is bigger is going to be the 7th month. So the answer would be 7. However, I want to show you how to simplify this so that you don't have to go scrolling up and up and up and dealing with these huge numbers. So let's talk about that. So I'm going to go back over here for a second. Remember earlier when I said that we could set these equal to each other and solve? I'm going to do that really quick. Set these equal to each other. So I have 500 times 2 to the x equals 5,000 x plus 10,000. So since I'm looking for the place where they cross, since that's the only point that I care about on the graph, I can simplify this as much as I want to, or as much as I can, sorry, and that will not change it will not change the x value of where they cross on the graph. So it won't change what I'm looking for if I set them equal to each other and simplify as much as I can. So what I'm going to do here is I'm just going to set them equal to each other, and then I'm going to divide everything by 5,000 because, sorry, not 5,000, 500, right? Because that's what I'm multiplying by over here. I'm going to divide everything by 500, and that will make my numbers smaller and easier to deal with. So I'm going to divide by 500. So you can totally do it the way that I initially showed. And you can also totally do it with guess and check. But this is going to give you, what I'm about to show you is going to give you the easiest graph. So the first graph that I showed you, like I said, it took a lot of scrolling to find that point. And so it's much easier if you can make the numbers smaller. So if I divide everything by 500, I'm going to have 2 to the x on this side, right? Because these cancel. 5,000 divided by 500 is 10. So I'm going to have 10x plus 10,000 divided by 500 is 20. So these graphs, they're going to look different from the original because they're a lot smaller, but the x value of where they cross, which is what we care about, remember, the x value of where they cross will be the same because I followed the rules of what you do to one side of the equation, you have to do to the other. So I haven't actually changed this equation, which is what we care about, okay? So the graphs are going to be different, but where they cross, the x value of where they cross is going to be the same. And that's what we care about. So remember, it's 2 to the x and 10x plus 20. That's what we're putting in our calculator. So I have that here. So I'm going to scroll out. So these are what my original graphs looked like. Notice they're super far apart at this point. I had to scroll way up in order to find that intersection point. So getting rid of those and putting in the new ones that we found. Now this is an intersection point, but at this intersection point, x is negative, which doesn't make any sense for our situation. So we're not going to use this one. We're going to zoom out a little. And we're going to use this one. Notice that this intersection point is very much more obviously an intersection point than what we were looking at in the previous graphs. That one was like, really? That's an intersection point? The only thing that told us it was an intersection point was this dot that they gave us, right? We couldn't really see it, but in this one we can see it because we've scaled it down, which is really nice. So notice when I hover over this, the x value, that 6.391, is the same as what we were looking at before. I've just scaled everything down. So I divide everything by 500 and I have a much easier graph to work with, and I still get the same answer. It's still between 6 and 7, which means the first month where B is bigger is going to be the 7th month. So 7 would be the answer to this. And I know this has been a long-winded explanation, but hopefully that helps with this. Again, you have basically two options here: guess and check, and graphing and looking for an intersection point. Hope that helps, and I will see you in the next video.